In this video, we will discuss even and odd functions and their special symmetric properties, and how you can easily analyze whether a function is even or odd. First, consider a function, let's say the x squared function, in which you input value x to obtain the output y. And you observe that if you enter the negative of the previous input, you again get the same output. Furthermore, you observe for more and more input values, every input has the same property, that the input and its negative gives the same output. Or to say, function value of x is always equal to the function value of negative x. And you reason that there is nothing special about this squaring function. So you generalize this function behavior by assigning it a name called even function. And you can even predict whether a function is even or not by just looking at its graph. And we can do it by reflecting one half of the graph about the y-axis. And after reflection, if two parts sit perfectly on each other, then the function is even. And we say that the even function is symmetric about the y-axis. Now let's talk about the odd function. And this time you are playing with the function x cube graph. You input a number x to obtain some output y. And observe that if you enter the negative of the previous input, you get the negative of the previous output. And furthermore, you discover that this relation applies to every number in the function's domain. So you name a function like this an odd function. And you can easily predict if a function is odd or not by observing its graph. For example, in the x cube graph, when you reflect the upper part of the graph about the x-axis and then again you reflect the same part about the y-axis, the two parts sit perfectly on each other. So we say the function is an odd function and have symmetry about the origin. After considering even and odd functions, there is also x-axis symmetry graphs, in which the graph remains unchanged when you reflect it across the x-axis, or simply every input x gives two outputs that are negative of each other. But a graph having a x-axis symmetry is not a function graph, as it does not pass the vertical line test. And if you do not know what the vertical line test is, I have already made a video about it and included the link in the description. So to sum up, the even functions are symmetric about the y-axis and the odd functions are symmetric about the origin. And if you like the video, consider subscribing.